Welcome back to part 2 of the Neon Flex LED DS9 sign video. In part 1, we went over the materials, the design, and cutting it out. In part 2, we're going to be talking about putting it all together. Where do these capacitors and resistors go? What do I do with this Arduino Micro Pro? Well, we'll go over all that, plus the coding of the Arduino Micro Pro. But before we get into all that, we need to give a shout out to our sponsor, CNC Labs, maker of the long mill. With 3 different options available, you can choose which size is right for your shop and your needs. Or if you're looking to upgrade your MK1 to the new 48 inches on the X-axis, that's available too. So go check them out down in the links below. Let's get into this video. Start off, I cut down my LED strips to the size I needed by running them in, and then I gave myself a little bit of room at the end, but I knew I was going to have to solder on new connections because the JST connectors would not fit through the holes I cut. So I knew I was going to have to solder on wires to go through, and I figured I might as well also solder up the power connection as well. And you'll see, I soldered it up and then had to cut it because I forgot the shrink wrap on them. So remember to put your shrink on wrap on first before you cut. After that, I used some plastic weld to put the wall mounting device together. Now it seemed okay, but it still didn't seem to have the strength that I wanted, so I added some super glue just to make sure it all held. Then after that, we took our soldered wires, ran them through there, measured out where they needed to be, then cut. And remember, you need to cut on the lines of the LED, like below. Then just take a little bit of this silicone glue if you're using this. A little goes a long way, and I did have some come up the edges, so be careful in how much you use there. And then I just used some clamps to hold everything in place and let it set. Now I let it set for over 12 hours because it was late at night when I did this, and that was how long it was going to take me to get back to it. You could probably wait a little less, but overall I was pretty happy with the results. Now you can see me here kind of cleaning up the edges where some of it came over. And then after that, I glued in the wall mounting brackets, and then I did it on both the front and the back. And again, I used super glue for that. After that, I wet sanded the edges of the black acrylic just to make it a little bit smoother to touch. It wasn't too bad, but I used the micron fiber paper, not regular sandpaper. I really like this stuff for acrylic. It does a really well job. And normally I use it for clear, but it works on colored acrylic as well. After that, we're going to start getting out all the wiring tools. Now you can see sometimes I have a resistor just kind of hanging into the Arduino. You can do that to test. I did eventually take all of the resistors and capacitor and put them all onto a breadboard, but we'll talk about the wiring diagram a little bit later. A couple key things while you are soldering and wiring something with this many wires. You can use painter's tape to hold multiple wires together, just kind of keep everything bundled together. Other thing, I think I've said it before in this video series, have a multimeter. It is going to help. And like I said on the power connector, make sure you have your shrink wrap on there before you start soldering wires together. Just saves you a lot of trouble. So, and another thing, when I was first started soldering stuff, I wasn't using flux. Invest in some flux. I'm telling you, it just makes life easier. It really does. It's a lot easier to solder when you do that. And again, the blue painter's tape is just great to have because you can stick things down, get them out of the way, and get to the wires you need. I'm not saying I am the best solderer or have the best skills in this, but we'll have to say it's somewhat relaxing. I really do like it. So I don't even have that fancy of a soldering iron. I think it was 20 bucks or less. So you don't need something fancy. And keep your hands out of the way. Getting soldering burns are not fun. I've done it once and never again. So always make sure and be careful and that you're conscious of where you're soldering and where your iron's at and where your hands are at. Now, the reason I went with the breadboard and using the resistors and everything there is because it's going to give me easier access and just a little bit easier to keep everything straight. Now, you could take the resistors and solder them to the wires and then put a shrink wrap over it. You could easily do that. I had the capacitor and wasn't sure how I wanted to mount that, so I figured put all the resistors and capacitors on a breadboard. And yes, I went a little bit overkill on the size of my breadboard, but hey, this is for me. It works for this project. If you're doing something a little bit more professional, of course, you're going to want to close this in and then find a way to also attach the Arduino to the breadboard. In the end, I did end up gluing the breadboard standoffs, the breadboard and the standoffs to the back of it, just so it wasn't flopping around, and made it a little bit more sturdy, as well as the Arduino. I used a double-sided tape to tape that to my acrylic piece I cut out for the holder, and then glued that as well to the back of the board. And before we finish all this up, let's jump into the actual wiring. Where does everything go? And then we'll come back and finish putting it all together. So instead of trying to walk you through and point out and pull apart all the wires that you see on mine, let's go over this diagram of my wiring setup, which is a little bit more tidy. So we're going to start here at the 5-volt power adapter. So this is our power brick. These two pluses that you see is actually just one wire that you can split. So your positive, you'll have one positive going off and into the Arduino and the other one going over to the capacitor. But let's talk about this first one here going up and into the raw pin on the Arduino Pro Micro. So we're putting 5 volts in, and this is going to power on our Pro Micro. That is why I was saying having that switch is very helpful, so you can turn the power on and off on it real quick, especially if you're testing out code and wanting to upload. That's just one less thing having to unplug, plug back in if you're using the barrel to connect that raw 5-volt power in. And then underneath that, you'll see is the ground, and we'll run that straight into there as well. All right, so we got 5 volts coming into the Arduino Pro Micro. It turns on, and we're going to need to run power out. And so that is going to be this VCC pin here, and it comes out, down, and into the LED strip. Now VCC out, we can see it says 5 volts right here. Well, the Arduino Pro Micro as is comes as a 3.3, I believe, volts out. So to get it to output 5 volts on that VCC pin, we're going to need to jump this J1 part of the board. And you'll see 2 metal lines there. Just get some solder and connect those 2 points, and that will put 5 volts out on your VCC pin. And then you can always double check that with your multimeter, make sure you're getting 5 volts. Now, you're not going to get a solid 5 volts out, especially if you start using other stuff on your Arduino. So that is why we have this second power coming out and coming into this capacitor. Now, if we look at the capacitor, we do have a positive and negative side. And you can see this blue stripe on the side of the capacitor with these negative marks. That is your negative side. The other side is going to be straight solid color. That is your positive. So we need to make sure we run our positive to the non-blue striped side with the 2 negative on it. And then make sure you run your other ground to the ground of that capacitor. Then we'll run that both that ground and that positive wire up into the 5-volt connector on the LED. Now, if you're looking at this going, Paul, why is this upside down and backwards? Well, look at those arrows. See, we have those in arrows. That is telling us which way that is telling us the direction everything is going to flow in these LED strips. So be mindful of the arrows. Now, if you have an LED strip and it has 4 connectors, you're looking at a 12-volt LED strip. You're going to have a bigger power supply, and if you want to power both off of one power cable, you're going to have to do some power converting. That is why I went with the WS2812B lighting strips. They're 5 volts. The Arduino to power on is 5 volts. No power conversion. Everything can come from one power source, and I don't have to go and convert power down to 5 volts from 12 volts and mess with all that. So yes, I did run 5 volts from the VCC into the LEDs and 5 volts from the power adapter. Let's say you just had a strip of 8 or 10, you might be able to actually power all 8 or 10 of those LEDs. But if you start getting 20, 40, 60, 80, 100, you're going to run into issues. So that is why you need this straight 5 volts coming through here. Because remember, again, this coming off the VCC is going to dip below 5 volts, using up power to run the Arduino and other things on the board. So that is why we need this extra 5 volts coming in. Make sure we can power a bunch of LEDs. Another thing, do not have your USB and raw power both on at the same time. You can run into issues and you might have to end up resetting your board. Yes, I went through that. It is not fun resetting these Pro Micro boards. There's no reset button on them. So you literally have to get a wire and short it out basically between the reset and the ground. So just be cautious of that. And last but not least, in regards to power, you can see here, yes, I have one running here and one running here. These here and these here all connect here. I just didn't want to have a bunch of more crossing lines all right here and everything getting confusing, but these right here correspond to these, and these negatives correspond to these negatives here. Now, let's talk about the data pins. So, you could use pins 2 through 9 on the left side, or you could use pins 10, 16, 14, and 15 on the right side, or you could mix and match which pins you use. I like to use all the same pins for my LEDs on one side. So we can see here, we got it hooked up to 4. It comes down and comes into this 330 ohm resistor. Resistors are not polarized as capacitors are. So you can flip this either way, but as a word of advice, I would keep all of them in the same orientation. Just makes it look nicer. And then we have it coming out and into the middle connector on the LED, the DN. You can see here, that means, so it's the in. And if we look here, DO, that's out. So data in, data out. That is what those two are used for. So again, that's another way besides just looking at the arrows, you can tell you have these going in the right direction. And then last but not least, we have this 5 volt 2-pin button. So I'm going to tell you all this. I had a 24 volt LED button that I was trying to use with this, and it caused so many problems. Why? Because I wasn't using 24 volts, let alone 12. So I only got 5 volts, and in the video of this put together, you're going to see that 24 volt pin. But in the end, I used this 5 volt pin. And no, I did not cut a hole big enough for it to go in. I just had to super glue it up to the bottom of the standoff. But this is real simple. One wire going into the ground, and then one wire going over to another pin. We're not going to use resistor on this because we're going to handle that in software, and we'll talk about that when we jump into the IDE. And yes, there's a lot of info there. Really, the most complicated part of this is getting all the power situated, your 5 volt and your grounds, and getting everything hooked up there. Everything else is pretty simple and pretty straightforward. And once we have everything wired together, we can go ahead and put in our secondary acrylic pieces. And I just use super glue, way too much. You don't need to use that much. Before you do glue those in, I would recommend cleaning out the silicone paste or the silicone glue before you do that, just so you don't run the chance of nicking up your acrylic. Okay, to get started with coding, we are going to need the Arduino IDE, and you can use the link down below to get to this page. We will be using version 2.0.0. If you're using an older version, you can still follow along. Once you're here, you'll need to download the correct version for your OS and then install. Once we get it installed, we'll be greeted with something like this. Now, before we jump into coding and going over that, we're going to need to load a few libraries. In the latest edition, you can come over here. It used to be under Tools and Manage Libraries. So either way, we're going to click right there. And then our first library is going to be Fast LED. And you can see I already have it installed. And then you just click the install button here, and it will install this library for you. Once you get Fast LED installed, you will need one button right there and click install. Those are the two libraries we will be using for this build. Also, you need to make sure we have the correct board. We're going to put micro. You'll need to make sure this is installed. We will be using the Arduino Micro board. And this is how you will be able to select it. If we come up here, you can see I already have an Arduino Micro. If we select this down one, if yours says something different, come here and select other boarded port. Type in micro. And there it is. And then hit OK. Next, you'll want to plug in your micro via the USB. You should hear that sound once it's plugged in. Then if we come up here, we can see Arduino Micro COM5. We'll select that, and then that means we are now connected to our Pro Micro. Now we can start coding. Let's go ahead and look at the code. Just like we had started with and making sure we had the libraries loaded into the IDE, we have our Fast LED and one button. These two lines are going to load the Fast LED and one button libraries onto our board for us. We don't have to worry or program anything on those sides. These are going to simplify our coding experience. We'll talk a little bit more about the Fast LED and one button later on. And see if we hover over here. You're going to, in the latest version, you're going to start seeing where these files are, and they're going to start giving you some pop-ups. Next, we're going to need to define our pins. So on my project, I am using pins 4, 2, and 7 for the LEDs. And then I am defining them: LED pin center, pin A, and pin B. So the A and B are the gold acrylic sides, with the center being the silver. And then we have our pin button, which is number 14. After that, we're going to tell it how many LEDs we have in each strip. So for our center, we got 139, and our sides 56 each. After that, we have some defining settings for our subloops, and we'll talk about some of those later. So down in our code below, right here, we're defining the arrays. This CRGB LED C, this is what we're going to use. LEDs C is what we'll use down below. We don't need to remember LED pin center or LED pin A or number of LED center. And so we just have to remember that's going to be our center. A and B will be our left and right. And that's what we'll use down in the code below. Here we have some more global variables that we will talk about. We'll get a little bit more into some of these things, the unit 8 and integers and all that. But for right now, we can use these to pull into any of our subloops or main loop to do certain things. Yes, I have a bunch of them up here. No, I'm not a professional coder. Yes, this was hacked together. If you really want to take a deeper dive into all this, go check out Scott Marley and Dave's Garage. They do great in-depth of really digging into this stuff even further. Right now, we're just doing an overview. Looking at what is possible. Here we have our one button definition. We're defining our one button and setting it up. As I had talked about earlier, we are not using resistor on the button. We're also not going to be using delay, and we also don't have to worry about debouncing the push button signal. But one button is going to definitely help us and speed up and give us great control over our project. We'll talk about it a little bit more, but let's jump into the void setup. Now the void setup, this runs once, and this is the first thing that's going to run. Now this is going to be one of the first things your Arduino, your Pro Micro is going to run to set up. So it only runs once. So we're going to initialize our LEDs here. That's what all this is saying here. Then we're going to initiate our brightness at 50. And then here is the serial begin. Now, if you want to monitor and debug your code, come here and take away those two slashes. Come up to here for your serial monitor, and it'll spit out down here. And next, we have btn.attach click next pattern. I want to come back to this because that will lead us into our next topic and kind of going over how the main loop works. So let's talk about this delay right now. So the delay function, I know a lot of people are going to frown upon it, but hear me out on this. This is the only delay used in this project. Now, when you use delay, you are not allowing the Arduino to do anything else but delay. It is not doing anything. If you want to look more into this, I would suggest looking up the millis function, which is a timing function, which is going to allow you to do other things and then come back to something after a certain amount of time has passed. So this delay is only giving us time to upload a new sketch onto our board in case something happens before the LEDs turn on, because let's say it was USB and it stalls out trying to power all the LEDs from the USB. This gives us time to upload a new sketch so we don't mess anything up and have to go use that reset function I was talking about earlier. All right, so what is this btn.attach click next pattern? So if we hover over the btn, the push button connected between pin 14 and ground, no resistor required. True. We're all set there. No resistor. And when we press the button on 14, it's going to run the next pattern. So let's come down here and look at next pattern. Before we get to our main loop, yes, we're skipping over that real quick, but we'll come back to it. So our next pattern, pattern counter equals pattern counter plus 1, percentage side 10. So what we're doing here is we are increasing what the pattern counter is on, and we have 10 of them. And then we have our fast LED clear. This is going to clear where all the LEDs, the current LED settings that we have. So our next pattern, we're going to the next. What are our patterns? Well, let's come over here. We're on line 66, and then you see it jumps to 107. But we have this nice little arrow here. So we'll press down. Hey, we got all our different patterns here. So as you can see, our main loop, this is the loop that's just going to repeat over and over and over and over again. Comparing that to the void setup, that runs once. This runs for infinity, unless of course you tell it to stop completely. So what happens here? Switch. Well, it will switch what case we're on when the pattern counter increases. Just like we were talking down here, pattern counter plus 1. When this first starts off, we start on case 0. Yes, 0, not 1, 0. They start counting at 0 and go up. As we had shown down here, we had 10 patterns. Case 0 through 9 gives us 10. So if we are on case 0, it's going to run solid color pattern. But if we press the button, it's going to come down here, add 1. The switch is going to recognize the pattern counter has changed and bring us to case 2 or case 1, the rainbow beat, and so on and so on and so on. Now, if you try putting solid color here and then adding another one here, is going to take the last pattern you put in. The solid color will never show. Just this rainbow beat will show. And why is that? So we come down here, fast LED.show. Now this is what tells the LED turn on. But before we can do that, we need to give it some instructions. What are we turning on? What are we doing? So let's go look at solid color. And if we scroll down here, solid color, let's ignore this part real quick and just focus on here. So fill solid. That is one of those fast LED instructions that we can use to tell all the LEDs on C how many and what color to turn on and fill a solid color. And we repeat that for both A and B. And of course, we need to label LEDs A and B here, and then the number of LEDs on each side, and then the color. We're saying we want to fill LED C, A, and B. Now, that is not alone going to turn or do anything. We're just saying what we want to do. Before the LEDs actually turn on, we need to say fast LED show. So if we look through all the patterns here, fast LED show is nowhere to be found in any of these other patterns. It is only right here. And that is what's actually going to show what we have told the LEDs to do. So it's going to keep looping through here, come back into our main loop, and then back into our pattern. And that is how you get an LED to show. Let's say we weren't doing a loop or had a button or anything like that. We would need to take this fast LED show. And if this was our main loop, we would need to put in fast LED show after all of that to get the LEDs to turn on. Now, if we took all of these fill solid away, the LEDs would do nothing. That is a quick basic of how to turn on your lights. Now, I know this one's called solid color, but then you might see all this right here: float, breathe, map, fast LED, set brightness, breathe. So in my solid color, I wanted it to kind of fluctuate between the brightness intensity. So I packed the breathing example into this one for this project. So all we're saying here is float. That means we want a number like float breath. So we're saying we're going to get a number that is not an integer, a full whole number. We're going to get a number like 3.146975, whatever. And we're going to call it breath. And that is equal to this long, fun equation right here. And we're not going to jump into everything, the sign, millis, and all of that. But this is going to generate a number for us. And then breath. Again, now we're going to map that breath between 0 and 255. You're going to see a lot of 0 to 255, but we'll talk about that later. And then you're going to see a min and max brightness. Min value, we can see here, if we hover over it, is 20, and max is 80. We set the min and max brightness up in our variables above. Now, what is map? We're saying take breathe, and then we're going to map it between 0 and 255, because our max bright can only be between 0 and 255. So we are mapping breath, whatever number was generated here. The second and the third one, the 0 and 255, that is the lower and upper bound of our range for brightness on the LEDs. And then we have the min bright and min max bright, which is the target range we want to convert that breath into. And then fast LED set brightness, breath. So now we're taking what we just mapped and setting the brightness. So we're going to get this inhale, exhale kind of feel with our LEDs. And then we're going to say, do these colors with them. It's going to come back and turn them on. And you're going to see the brightness getting brighter and getting softer in brightness. All right, let's take a quick look at RAINBOWBEAT. Now, unit 16_T, you're going to see unit 16 and 8. Basically, that is a byte number. And we're saying we want to set beat A is going to equal beat sign 16. And so this first number is the beats per minute. And then our next two numbers, 0 and 255, what we're saying is there, we want it to oscillate between 0 and 255. So if we look above, we're going to see our beat A is at 30 beats a minute. Our beat B is at 20 beats a minute. And then when we come down into the fill rainbow, we have our LEDs, our number of LEDs. And then we have beat A plus beat B divided by 2. That is going to give us the initial hue that we're going to start off with in our LEDs. And then that last number is the delta hue, and that is how fast we're going to advance the LED. And if you see, this is the effect we get on the rainbow beat with it moving through those different colors. Again, there's lots of fun stuff we can do here. We can see all these different patterns here. Now, I'm not going to get into the nitty-gritty of fire and how it all works, but more, let's talk about the philosophy of how I go about coding. One of the things when you're coding, well, let me rephrase that. When you're hacking and you're learning to code, come in here, play with variables, see what happens, change a variable, watch what happens on your LEDs, come back, change, play around, find what works, what doesn't. If you do that though, remember to save a copy of the original work so you always have a place to get back to a working starting place. As you can notice in mine says ComBadge B. This program did not start off with the name ComBadge B. It started with button press and then slowly progressed more and more and more as I added more and more stuff and changed names. And I get to a certain point where something's working. I save it and then save a copy of what I wanted to achieve next and name it that. And then by the time I have a good understanding of how I want the program to work and all the different pieces are going, then I name it the final, give it its final name. But as you can see, the fire has a lot of different things going on here. Some for loops, if, like I said, there's a lot of great videos out there. I have this all on my website, so you can go and hack it from there. Now let's come down here to gradient change slow. And when we get here, you can see now we have a fill gradient. And this one is the slow. And then I have gradient change fast. And if we just look to compare these real quick, we can see we have the start hue 4 and 8. And then the start hue 32 and 32 down here for the start and end. That's 4 beats per minute. So that's 4 beats per minute and 8 beats per minute, which is slower than 32 beats per minute. And if you really want to strobe it out, go up to 64, go up to 120. Play around, change these numbers around, and see what they do for you. Now, I'm going to pull up this one here. This is kind of my notes and just going over a couple of different things here. But let's talk about 3 of the different ways you can name and get a color. So if you put in CRGB : you can use the color name. So if we come back over here and we go to solid color, see I use slate gray here. And I'm going to leave a link down below where you can get all the different color names for the RGB color values. Or let's say you just want to use the RGB values. So you have your red value, your green value, and your blue value. And any of these can be 0 through 255. So off would be 0, 0, 0. And if you just wanted red, 255, 0, 0. And then we have CHSV, hue, saturation, and value. So again, just like in RGB, we can make this hue 0 to 255 and get the hue, the saturation, and value. Again, there's a lot of great information out there that's going to dive deeper and go over the theory of all this. Now, one of the others, we kind of briefly talked about the unit 8 and unit 16. These are just integers in 8 bits or 16 bits. I'm not going to get too caught up in these. And for our understanding, this is like putting int for integer in front of a variable. Now, beat sign. Hey, I never took calculus. Thus, I'm not going to try to go into the math of it. So let's look at the numbers we can plug into beat sign and what they do. Specifically, let's look at gradient change fast. We have an integer that we want to declare this variable start hue underscore C, and it is equal to beat sign 8 32, 0, 255. That's all we're saying here, right? So then when we put that down into the fill gradient, the start hue C, see, we have this CHSV, what we were talking about in color earlier. And remember, H is for hue. So we are changing the hue here. Our saturation is going to be 255 and our value 255. Then when we get to the end of this fill gradient, the end hue is our hue. And then I changed it up. The saturation is our start hue. And then our value is 255. So these can be variables. See, we can put in solid numbers. We can change these around, mix and match and try different things. Don't let it scare you. Like I said earlier, save copies of working stuff and then save a new one and call it COM-Badge B playing around. This whole line is not that complicated, you know, if we break it down. Fill gradient. Which ones? LED C. Number of LEDs? The center, 139. We want the start gradient here, the end gradient, and then we want it to go forward. So play around with these, check them out, do different things. If you have any questions, leave them down below. So this is basically just a delay function right here, what you're looking at. That's all this millis is. If unsigned long current millis is greater than or equal to interval B, which I have set for 100, fill this, do this part right here. This is a delay, but with this, as opposed to, so if I just said delay 100, it's going to wait 100 milliseconds before the Pro Micro does anything. But with this, it's going to keep going. It'll detect a button press, but it's going to come, oh, hey, it's been 100 milliseconds. I need to update this. That's all this is. I know it may look a little complicated, but it is not. So there is your delay, quote unquote, not delay feature. And I think that wraps it up for the coding part. If you got any questions, leave them down below. I'll try to answer as best as I, can. And if there's anyone else out there who might have the answers, they can answer down below as well. I am by no means an expert in any of this, but I love it. I find it so interesting and I keep learning. And that's part of this. You're never going to get anywhere if you don't do anything. And I know those are Arduino boards. You can get some very quote unquote pleasant people you can have to deal with when asking questions. But don't let them get you down. Believe me, at one point they were where we all were at. So ask questions. There are no dumb questions. It can sometimes take somebody a little bit of time to get their head wrapped around a certain idea or concept. The millis one took me a little bit to kind of get my head wrapped around in how that works. This whole fast LED and one button and getting away from the delay. It took me a little bit to get my head wrapped around that concept. So take your time. Go over to Scott Marley and Dave's Garage. They do excellent work in doing a real deep dive and giving great information on how this all works. I am not a computer programmer. I am not a electrical engineer. I am a hobbyist maker who finds this stuff interesting and whose dad was a programmer. So he has somewhat of a little bit of understanding on what's going on. So let's take a look at all these different patterns and what their final results are. that's going to wrap it up for this video. I have to say, I'm really excited how this turned out, and I hope it helps you and gets you making a Neon Flex sign as well. If you have any questions, leave them down below. And if you haven't already, hit that subscribe and bell button to keep up with all the latest DE Hammer videos. And we can't forget our sponsor, CNC Labs, maker of the long mill. Now, my long mill, it made cutting the acrylic the easiest part of this project. The hardest part, of course, was wiring and coding and getting all that working. So, if you're interested in getting a CNC machine, go check out the long mill at the links provided below. Well, thank you all for watching, and until next time, keep making stuff.